effect of a volume change. If you have reactants that are, or products that are gases, changing the volume is going to affect their concentration because it affects the pressure. So if you change the volume of a gas, that changes the pressure. Decreasing the volume, imagine a balloon. If you want to decrease the volume of the balloon, that's going to increase the pressure of the gas, right? If you increase the volume of the balloon, you expand it without changing the temperature or the amount of gas inside, then the pressure is going to go down. We've got the ideal gas law, PV equals nRT. N is the number of moles. So this equality is true. If I reduce N, if I lower the number of moles, and keep R, T, and V the same, what's that going to do to the pressure? It's going to decrease. So you can think of it in terms of the ideal gas law. You can also think of it in terms of a balloon. If I remove some of the gas, what does that do to the pressure? It decreases it. If I put more gas molecules in, then the pressure goes up. Okay, so there's a relationship between the pressure of a gas and the number of moles. If you change the pressure of the reaction container, the system can shift to relieve that by changing how many moles of gas are present. So in this reaction, N2 plus 3H2 makes 2NH3. So on the left side of the reaction arrow, we have a total of 4 moles of gas. 1 nitrogen and 3 hydrogens. So there's 3 plus 1, 4 moles of gas. On the right side of the equation, you have 2 moles of gas. So when the reaction goes in the forward direction, the result is you have fewer gas particles because they're combining with each other. This is kind of like carpooling. It's like, oh, let's all jam into 2 vehicles instead of having 4. In the reverse reaction, you're taking these carpools and you're breaking them up, and now you've got more cars. Does that make sense? If we decrease the volume of this container, what does that do to the pressure? It increases. Does the equilibrium like that? No. No. What can I do to get rid of this pressure? Well, I'm going to double people up. I want to make them into smaller, fewer particles, really, not smaller, but fewer particles to relieve the pressure. Because 2 moles of gas is going to exert half the pressure of 4 moles of gas. It doesn't matter what they are, because with gases there's so much empty space that the size of the molecule doesn't matter at all. People in Wyoming versus people in an elevator, right? So you increase the pressure, the system says, I don't like that, I want to reduce the pressure. It's going to shift to the side that has fewer moles of gas. And you tell that just by looking at the chemical equation. If we increase the volume, that decreases the pressure. Right? So we've made this bigger, the gas will expand to fill it, now the pressure is less, the equilibrium doesn't like that shift either. It's just like one of those ornery people. I can be that ornery people. I can't be more than one person. I can be an ornery person. It's like I don't like it if you make it hotter. I don't like it if you make it colder. I just want it the way it is right now. Don't rock the boat. So we have expanded it. It doesn't like that either. That lowers the pressure. To increase the pressure, it's going to shift to this side because it'll have more particles. And so that will help bring the pressure back up. Does that make sense? Effect of a volume change. Decreasing the volume will cause the reaction to shift in a direction that has fewer moles of gas particles. Increasing the volume causes it to shift to the side with more moles of gas particles. If the number of gas particles on both sides of the chemical equation is equal, then changing the volume is not going to have any effect on the equilibrium because it's not going to help. Shifting the reaction won't help. Let's look at this reaction. 2SO2 plus O2 is in equilibrium with 2SO3. What is the effect of decreasing the volume of the reaction mixture? So this, you have this reaction in a container. We're going to make the volume smaller. It's going to go to the right. On this side, we have 2 moles of gas. On this side, we have 3 moles. 2 moles of SO2 and 1 of O2. So when we decrease the volume, it's increasing the pressure, and the gas wants to undo that. The equilibrium wants to undo that. And so it's going to shift to the right where there are fewer gas molecules. What if we increase the volume? It's going to lower the pressure, and the reaction will try to shift to replace that pressure. And so going to the left will increase the number of gas particles and bring the pressure back up.